All right, sorry about that. I had somebody knock on my door and I accidentally cut it off. So here we go. So we spent a lot of time on this graph when we did on Google Draw, solid, liquid, gas, plasma, and the energy, how it changes in the phase changes. So we discussed this in depth. So going from a solid to a liquid is melting. So I have a little plus sign here showing that it's adding energy in order to do that. Liquid to solid is called freezing, and you take away energy. Liquid to gas is vaporization. We're adding energy, the little plus sign. Condensation is going from a gas back to a liquid. That's the minus sign. Gas to a plasma is called ionization, so that's a plus sign. Plasma back to a gas is called recombination. That's a negative sign because, again, this is talking about the energy. So that's adding energy, and that's taking away energy away. Gas is here, so there is a phase change that can go for directly between solid and gas with skipping over the liquid part. So solid to gas is called sublimation, and that's adding energy. Gas to solid is called deposition, and that's taking away energy. So also, not only if the plus minus signs, but over here it's got a star beside the phase changes, and the star notes that energy is being added. And then if it's got this is called a caret, it looks a little upside down V, arrow top kind of, recombining, condensation, freezing, and deposition, that notes that energy is being removed. So it tells you that as well there. Now we also spent a lot of time on this one that's on the bottom. We talked about how something's in a solid form and then it hits the melting point. We did the temperatures for water here. So this becomes a freezing melting point. Freezing and melting actually happen at the exact same temperature. And one of the things we discussed about is how the temperature stays the same between these 2 points. So if the temperature stays the same between here, but we are also adding energy to that part right there. So if I add energy, but the temperature stays the same, that energy has to be doing something. So what's happening in between here is that the energy is being used to overcome the attractive forces between the atoms that are making up that solid and liquid. So again, freezing and melting, we've got the positive sign here, we've got the negative sign here. Melting is increasing in energy, freezing is decreasing in energy. Then we've got this next phase of matter. This is liquid. So all the time through here, the heat energy is being added and the temperature is rising because everything in here is a liquid. Once it hits this temperature for water, it's 100 degrees Celsius, and that's going to become the boiling point, what we call it, vaporization point. That includes evaporation and boiling. So going from a liquid to a gas is vaporization, you're adding energy. A gas back to a liquid is condensation, you're taking away energy there. So this section, again, it flatlines or plateaus. That means that the energy is going, it's being added, especially if you're going in that direction. However, the temperature is not changing because all of the energy that's being added is being used to overcome the forces. And then, of course, you go to a gas. I could take this up an extra level and go to like plasma and go on up, but they normally don't do that because normally that's just what you see, solid, liquid, and gas. So that's how you read that diagram. Then on page 27, we did the guided notes here on page 27 for the phases of matter. We did those together as class and we went over the answers. So if you need to pause the video and make sure you have those answers correct, you can do so now. All right, page 27, then you flip over page 28. On 28, we turn to the side and we did this together in class. We drew our molecular models here. This is our visual representation of the particles of what's going on. We talked about the shapes. Solids fixed, liquid, gas, and plasma, those change shapes. And then we just chose one of those on each there. So you can pause that and make sure you have those. But remember, we went back over the particle arrangement, the volume, the movement, and the energy level there. All right, if you look at page 29, we did this. And these were our comprehension questions that we did together in class. So we did those, and I gave you time to work on them. Some people had to take that home and finish those for homework, and then we went over the answers the next day. And there are the answers for 1 through 11 showing, and I'll scroll it down to do. There we go. Zoomed out a little bit. So there's 12 and 13. answers to those questions are at the top. All right, page 30. These were the gas laws. So gas laws, and notice this has a front and back. So what we did is we taped it just on one side so that we can flip it back and forth. So our gas laws, we read this together in class, and we talked about each of the gas laws. So we learned that Boyle's law has a constant temperature, and that volume and pressure are inversely proportional. I showed you a marshmallow in a syringe, so that was an example. I squeezed I increased the volume there, and it decreased the pressure, and so the marshmallows kind of blew up. I can do it right here for you, actually. I have them still here from class today. So if I take this and I see the air is right here. So if I decrease the volume, I'm increasing the pressure. So if I do that, my marshmallows are actually going to get smaller and smaller, and they kind of crunch up there. I don't know if you can see that real good. And then if I go opposite, if I pull it this way, the marshmallows are going to enlarge. So let me set that up so I can pull enough air out of those that you can see a difference. So there's my marshmallows, and I'm going to increase the volume, and that's decreasing the pressure. So here we go. And you can see that those marshmallows about doubled in size when I decreased the pressure by increasing the volume. So we did that in class. And we also talked about the water bottle, making it pop. So that's this one, because VIP, volume, is an inverse to pressure. And this is what that would look like on the graph. As the pressure increases, the volume actually decreases. All right, here, thermal expansion. The next one, Charles's law. We're talking about something at a constant pressure. We talked about that today, and this is the graph. Constant pressure, the volume of the gas increases as the temperature increases. So these are directly related to each other. So we talked about thermal expansion when we did the ivory soap in the microwave. We put it in there and heated up the little air bubbles that were in between the soap particles, and it expanded and pushed that soap out. So when I increased the temperature there, that increased the volume of the gas. You can also see this like inside of a container that's flexible. You can see that happen like with a balloon. If you put a balloon in the freezer, or if you heated it up, it would expand or contract. So that would show you that. Right here, on the back side is Gay-Lussac's law. In Gay-Lussac's law, we talked about a constant volume. So the two things that were changing were pressure and temperature. So as the pressure goes up, the temperature goes up, pressure goes down, temperature goes down, and this is what that would look like on a graph because they're directly related. And our examples here were a basketball or tires in a car. We talked about that was a fixed volume. The volume's constant is a fixed container. So your basketball or the tire is a fixed container. And we use those as examples. In the wintertime, your tires, pressure light may come on because of this law right here, because as the temperature decreases, so does the air pressure in the tires because the molecules are slowing down and pulling closer together. So density right here. Density is what sinks and what floats. So when we're talking about density, it can change. This is not a gas law, but it is a relationship between density and temperature and density and pressure. So for temperature, the thing is like hot air rises, right? So air is a gas, and so when gases increase in temperature, they actually decrease in density. So because it's less dense, it's going to become to rise. So that's right here. This is like a hot air balloon, right? So if you think about, you could even draw a hot air balloon. Well, that's not very good. And there's my basket of the hot air balloon. So you got a flame going up there, you got your particles in here. Those are going to be less dense, right? And these are going to be more dense that are around here. These particles that are all over the ground and outside there are going to be really close together compared to the ones that are inside the balloon. Not, of course, like a solid or liquid, but closer together than the ones in here. So if I increase that temperature, I'm going to decrease the density. So that's going to actually float up into the air. And then the other one here is about for pressure. So if I can change the pressure, the air pressure, I'm actually going to change the density as well. So as I climb a mountain or go up in an airplane, the air pressure actually will decrease because the density of the air has decreased. So if you decrease the pressure, you decrease the density of the air because there's less amount of air in the same amount of space. All right, so those are a couple things with density and pressure. And here is our graphic organizer with volume, temperature, and pressure. We talked about volume being space. We really keyed in on space, with pressure being force. And then this one right here, the amount of average kinetic energy of the particles. Those are the three things that measure temperature. Remember, temperature is a measurement, right? That measures. Then we did a little strip in the class like this with volume, temperature, and pressure. I don't know if I can zoom out enough to kind of demonstrate that again for everybody. But if I hold temperature constant and I move pressure, pressure goes up, volume goes down. If I move volume up, pressure goes down because temperature is constant. So in our laws, remember, one thing is constant while the other two things are changing. If you remember volume, temperature, pressure in that order, and I always say VIP because then my I becomes my T in the middle. VIP, very important, people. As one goes up, the other one goes up. And so over here, same thing. So if I hold pressure constant, volume goes up, temperature goes up, volume goes down, temperature goes down. And so we wrote those down here at the bottom onto our chart. But the volume and pressure are inverses of each other, and your temperature stays constant. Temperature and volume are direct relationship, up and up, down and down, while your pressure is constant. Up and up, down and down, volume stays constant, pressure, temperature. So those are direct relationships, and that one's inverse. So that kind of summarizes so far what should be in your notebook. Up to page 31. We are going to be working on page 32 tomorrow in class. I already have it, so this is what should be on page 32 about a phase change diagram. There we go. Phase change, solid, liquid, gases, triple point, critical point. And then we're going to do these practices together. So we're going to put those in there, and there's the answers to those. And we'll do that together in class. And then we're going to do some comprehension check questions right here tomorrow in class as well for gas laws and our phase change diagram. So that's what we have, and all of that stuff is what's going to be on chapter or unit 2 test. So from page, in your notebook, from page 21 to page 34, those are the things that are going to be tested. And so if you can do all those things on those I can statements, and you understand those I can statements, and you understand the vocabulary that's being used to ask the questions, then you should be just fine. If you need extra help, there is a Google Classroom for support. I encourage you to go there and join that class. I will post the link into your Google Classroom for help if you want to join that class. All right.